Okay guys, I'm back. Again, sorry for the last video where there was all the scratching noise. I've rolled my sleeves up this time and it's now almost 7:15. So this is part 2, okay, of the chapter 2 solutions. So we're starting on number 10. And on number 10, A through D, it wants us to write the transformed function equations and then is the inverse of function y or y not. Okay, so I'll do a couple of those. All right, so the first thing I noticed on 10A, all right, is that I have an absolute value. Sorry, my voice. I have an absolute value, okay, because it looks like a V. I also am looking at the vertex, and so I know the parent function for this one right here is at 0, 0. However, the vertex on our transformed equation is at 3, negative 2. So this is my h value and this is my k value because it's been transformed 3 to the right and then 2 down. So in that case, what I'll do is I'll say, hey, let me take my standard transformation equation for an absolute value and let's plug in those h and k values. So we have y is equal to a, x, again we went to the right, so minus 3, and then we did minus 2. And then also I noticed that I'm going to choose a point off of the function, so I'm going to choose 0, 1. 0, 1. Alright, so there's my x value, this is my y value. So I'm going to do 1 is equal to, I'm trying to find the a value. X is 0, minus 3, minus 2. So 1 is equal to a. This is the absolute value of negative 3. Okay. So then I'm going to rearrange this and put 3a minus 2. So I'm going to add 2 to this side. So I have 3 is equal to 3a. So a is equal to 1. All right. So as you can see, we have no vertical stretch or compression, and the final answer would be y is equal to, we don't have to write the 1, but we'll just write absolute value x minus 3 minus 2. Okay, and let's see. When it says, is this an inverse function? Remember, if it's an inverse function, you take the original function and it has to pass the horizontal line test. So when I think about this absolute value equation or function, if I put a horizontal line, you see it fails. So this one, it fails. So since it fails, then I'm going to say to you, no, does not have an inverse. Y or why not fails the HLT. And that's that, okay? So let's go on to 10B. You can pause it as you need to. All right, for 10B, I noticed that it's a cubic. So I say y is equal to x cubed. I also noticed that if I just kind of sketch in my mind or look at that worksheet that I gave you guys on parent functions, you know, I know that he snakes. I completely missed the origin. Goodness, okay? So let me try this again. So he snakes through the origin. Bloop, there he is. Okay, so if that point is right there at 0, 0, on my parent function, I look at the picture that I have on 10B and I notice, hey, not only is he going the other direction, which he actually looks something like this, okay, so I'm going to focus on the point that's right here, and this one was negative 1, 2. So this is my h and k value, all right. I also know there's a reflection of some sort, right, and he's facing, you know, the opposite direction. So I'm going to write a, and again it's a cubic, so we're going to put the cubic function around our standard transformation equation, and I'm going to plug in my h and k values. So I have a, and then for our h we said it was a minus 1, so we should get a plus 1, and our k is a 2. Just double checking on that. Yes. Okay, so now what we're going to do is we say, hey, let's choose a point. Now I'm not going to use this value, but I'm going to choose another one. So kind of down here they tell me that at 1, negative 10, there's a point on this cubic function. So I'm going to let this be my y value. Here's my x value. You can zoom in to see this. I'm going to write it a little bit bigger. So let's do negative 10. We're looking for a. We got 1 plus 1. Uh-oh, don't forget the cube. Glad I caught that. You guys aren't here with me, so I got to catch stuff. All right, so now I have negative 10 A, again, that's 2 cubed, so that's where I get 8 from. Subtract 2, subtract 2. And so we get negative 12 is equal to, I'm going to just put that coefficient in the front, divide by 8. Okay, so I have A is equal to, and then I'm reducing these both by dividing them by 4. So that will become a 3, divide that by 4, that becomes a 2, so negative 3 halves. Okay, which is great, right? Because there was a reflection, so my A is negative, so there must be a reflection across the x-axis, not the y, all right? Because think about it, if I reflect this guy down, see there's this piece here, and this guy went up, sorry about that sound, okay? So then that means, sorry, I'm going to turn this down. Malfunction, I don't know how to use the phone, go away. Boop, boop. Okay, so A is equal to that, so here's our final answer. Y is equal to, oh, I have 2 colors, really? I didn't know I could do that. Y is equal to negative 3 halves, open parentheses, x plus 1 cubed, and then plus 2 in the back. This is the final answer. And again, it has a reflection. I think I stopped in the middle of my thought. So again, it reflected across the x and then across the x there. So reflection across x-axis. Okay. It also went shifted 1 left and then shift 2 up. So those are all the things that happen. Also, I noticed that since A is equal to negative 3 halves, right, guys? If I take the absolute value of this, that changes it to a positive 3 halves, which is 1.5. And so when A is greater than 1, what do we say it has? It has a vertical stretch. Again, refer back to the PowerPoint that talked about when A is greater or A is a fraction, when B is greater than 1 and B is a fraction. All right, so that takes care of everything. The answer was this one. The question now is, does this guy have an inverse? Is the inverse a function? So if I go back to here, look at the red one, and if I put a horizontal line, test, yes, he has an inverse. So yes, has an inverse, whoops, has an inverse function, excuse me. And if they asked you, right, how to give us that function that's the inverse, remember we would switch the x and the y, take our time and resolve for y, and that would be the answer. Another good thing you could do is you could take those points that are on the red line, remember, and switch them, you know, b comma a instead of ab, and then that will give you the inverse as well. All right? Okay. All right, let's look at 10c. So when I look at it, I already know that it's a rational function. And also, if you look very carefully at the picture, there is a vertical asymptote at x equal negative 2. There's a vertical asymptote there. At y equal, I think, positive 1, right? Yeah. At y equal 1 is a horizontal asymptote. So that means that it's shifted 2 left. Sorry for all the clicking. I'm going to learn how to make videos without the clicking sound, okay? Just bear with me right now. And then we went 1 up. Okay? Bloop. All right, now, that being said, I know that the equation should be a 1 over x minus h like that, and then plus k in the back. So I'm going to plug in, I don't know what a is, but it went 2 to the left, correct? So h is negative 2. K is 1. So I'm going to get 1 over x plus 2. And then I'm going to do plus 1 back here. I think that's what I got. Okay. Then if we look very carefully, they gave us the point on this rational or reciprocal function of negative 3, because it's in quadrant 3. That was a negative 2. Okay, so this is going to be my x, and here's my y. I hope you guys, as you practice this stuff is really straightforward, okay? So we got negative 2. Very proud of you guys. I want A's on my test, all right? Plug in negative 3 here, plus 1. And then I know this right here evaluates to negative 1. So negative 2 equals negative 1a, or you could put negative a, plus 1. I'm going to subtract 1 to both sides. So I'm going to move over here. Oh no, let's just stay here. Negative 3 equals negative a. So I got a is equal to 3. But the first time I did it, I did not get that. What did I do? negative x. Yeah, I should believe in myself. Negative a plus 1. Yep, okay. I got a is 3, guys. I don't know why the first time I did it, I did not get that. Oh well. So here's the answer. Y is equal to, again, if you find a discrepancy, email me, all right? So I got y is equal to 3, open parentheses, 1 over x plus 2 plus 1. And again, this is kind of hard to tell. I mean, but right now it's saying, because a is greater than 3, it's saying that we have a vertical stretch. And you can't really tell, huh? Vertical stretch. They look pretty like they're getting pulled up maybe close to the asymptotes. But again, this is what I got. All right, now, does it pass the horizontal line test? It does. So I would say this one also has an inverse. Why? Because it passes the horizontal line test. Okay, and again, just, you know, you can graph it and then just look at it. Okay, if you want to put the parent function on top of this one, that way you can see if it changed. So that would be how I do it. And again, I'm limited with time, but I could open up Desmos, put the parent function, okay, which is this one right here, and then compare it to what we say we have, and then we can look at, you know, if it's more stretched. All right, last one. I'm just going to give the answer to this one, 10D. So for this one, it is a quadratic. I noticed that the vertex is not at 0, 0 like it normally is. It's now been moved to, I'm looking really carefully, -1, -8. So that tells me I went shift 1 left, shift 8 units down. Okay, shift 8 units down. So that means that if I go and write my standard transformation equation here, put a square, I'm going to plug in my h and k. Here's the h, and there's the k. So y is equal to a, x, went to the left, so plus 1, and then we went down -8 back there, right? You guys got it. So then I also look on here and notice they gave me the point on the picture, +1, 0, was the x-intercept, or one of the zeros for my quadratic. So there's the x, there's the y. So we got 0 is equal to a, plug in 1 plus 1 squared. So 0 is equal to, again, this is 1 squared. Yep, so a minus 8. So according to this, add the 8 over, a is equal to +8. Okay. And if a is equal to +8, oh, I know what I did wrong. Hello. There should be a 2 here, sorry. 1 plus 1 is 2, 2 squared. This should be a 4. I gotta stop, I gotta lay off. Okay, so then I'm going to add the 8 over and then divide. So you should get a is equal to 2. I caught it. All right, so we got y is equal to 2. We got x plus 1 squared, and then -8 in the back. So this is the answer for our transformation equation. And then this one, of course, because it is quadratic, it fails the horizontal line test. So we're going to say no inverse to this function. No inverse function. All right, I hope that makes sense, and that one took a little while. Okay, so again, go back over them very carefully on how I got my answers. I think I boxed everything. I didn't box this one. Okay, all right, so I'm going to move on. Moving everything out the way. Okay, let's now look at number 11. Okay, so for number 11, just want to finish this page, maybe 3 videos. So we have f of x is equal to the square root of x. And what they wrote is, they have the f function, they have this -2x closed and a -3. So what you should get from this is that inside of the function, and the function is a square root, basically, since that -2 is with x, then there's something happening with b. So we got horizontal stretch compression stuff, and we have a reflection across the y-axis. So that tells me about the reflection, okay, across the y-axis. And then because these two guys are in there together, again, I know that this has to do with b. So let's put this in perspective. We have now y is equal to square root, and under here we should have -2x is under the radical, and there's a -3 in the back. So this is the proper way of looking at it, okay? Now, there is no h value, so there is no shift left or right. So I can tell that because there's no h. However, it did shift 3 units down. 3 units down. Okay, the a is equal to 1, which would be right here in front of the square root. So as of right now, what I'm going to focus on, to get my rule and everything, is I'm going to focus on that, hey, right now I can tell that b is this value. So I know b is equal to -2. And when you want to do the rule, remember it goes 1 over b, x plus h like that, comma, ay plus k. So when I apply this rule, here's what happens. So I have basically 1 over -2, because that's my b value. There is no h in this case. So basically the rule is going to be take all my x values, multiply by -1/2. My a is 1, I got y, and then my k was -3. So here's the rule that I need to use to transform points from parent function. Again, in our parent function above, like I just said, is a square root. So the first thing I should do is take my parent function values, parent, and I know major points or key points, use that worksheet, are 0, 0. I know that 1, 1 is on there. I also know that 4, 2, and 9, 3 are key points for the parent function. And now I'm applying the rule, so I'm going to change colors. How do I just do you? Alright, I don't know what's going on. Hopefully it lets me be in red. So now when I transform using the rule, I'm going to get the following. I'm going to get 0 and -3, -1/2 and -2, -2 and -1, and then I'm going to get -9/2, comma, 0. So again, I took these points here, right here, hope you can see my cursor, and then I just applied this rule and I came up with those points, right? So, 0 times -1/2, 0, 0 minus 3, -3, and so forth. Okay, take your time and look at it. So now when I sketch this, here's what I have. So on your little graph, you should have the tail is at -4, okay? I'm sorry, -3, right here. Then when I plot, again, I'm going to over-exaggerate. Here is -1/2 right there, and it goes to -2, so I'm just saying, hey, about right here. And then they have -2, 1, so let's call this guy over here -2, and then right here would be -1. I know my spacing is absolutely terrible, but you get the point. And then over here, I know that -9/2 is -4.5, so here's -3, here's -4, so somewhere over here, there's -5. Right here at -4.50, there's my x-intercept. So basically this guy should go here, curve and go through there. It looks terrible, but you guys do it better than me. So again, he looked just like this. He came from here at -3, and then he goes like that. Again, make him look better. So that's what you should get. And then they said describe the domain and range in interval notation. So the domain, I notice, is that I can go from -infinity all the way to 0. Again, I'm looking at, I'm going to just slash all over this thing, okay? I'm looking at, hey, I got all these x values that are negative, and then it stops right here at 0 from left to right. Then for the range, I'm looking bottom up, and I'm saying, hey, my lowest value is -3, and it's going up to positive infinity. So we're going to put bracket -3 to infinity. Okay, so again, I look from bottom upward, and then here I look left to right. All right, that takes care of number 11. Last one, number 12 on this page. Again, all these, I'm sorry, they're all like 20 minutes. For number 12, it says, hey, you have a reciprocal function, a transformed reciprocal function, so I know my brain thinks of that. It has an asymptote at -2, and it has a vertical asymptote. So here's your horizontal, sorry, dang it. This is the horizontal. The top one is vertical. This is a vertical. And it says it passes the point -4, comma 4. All right, so with that information, I'm automatically telling myself, all right, well, I got my reciprocal function. I got x equal -2, so it went to the left. So I got 1 over x plus 2. And then it went 3 up, So I'll put this in the back. Y. And again, I still probably have to solve for an A. And then I have my X and my Y. Okay. So we got 4 is equal to A, 1 over, whoops, put a 4 there. Put a negative 4. And then this becomes 4 equals A. This is negative 2. So this is 1/2, like that, negative 1/2. And then plus 3 in the back. So we're going to subtract that 3 over and get 1. So we have 1 is equal to negative 1/2 A. I'm going to multiply by negative 2 because, again, I want to do the reciprocal and I want a positive A. So multiply by negative 2 over here. So this becomes an A equals negative 2. A is equal to negative 2. Got it. So the final answer is Y equals negative 2, open parentheses, 1 over x plus 2 plus 3. And this is the transformed equation. And they gave a description. All right, I'm going to stop there and we'll move to part 3. All right, thanks, guys.